I'm going to perform a little exercise here because I'm too lazy to draw. So here I got a roll of toilet paper representing a coil of wire, and then I've got a little bottle in the center representing what would be the ferromagnetic material in the center of the hollow, what would have been in the hollow core of the coil had it not been there. Now I want to make equivalencies about various phenomenon that I'm trying to represent here. So the equivalencies are between parallel capacitance and magnetic remanence, and also paramagnetism, oddly enough. Now, what we want to occur in over-unity circuits, somehow or another, it doesn't matter how, we want to create a total reversal of current relative to voltage by 180 degrees angular phase shift, 1/2 cycle. And under those conditions, we will get the definition of a generator in which the reactance is so totally reactive and the wattage is zero that no load can see it other than a resistive load. No reactive load can see this reactance, and the reactance cannot see any reactive load. So the energy of the reactance cannot dissipate. All it can do is accumulate because it keeps making copies of itself every half cycle or every quarter cycle. I'm starting to be not clear how often it happens, but it happens very quickly. Actually, no. It's every half cycle. What happens is when you have current reversed to voltage, a cycle is not a cycle anymore. It has no significance. There's no such thing as a cycle. Because everything is inverted, the only phenomenon that exists is a half cycle. That becomes your new unit of measurement of time, of an oscillation. And furthermore, every half cycle keeps getting subdivided, because in order to create a half cycle, in order to create reversal of current relative to voltage, you have to get inductive reactance and capacitive reactance to occur simultaneously. And since they are 90 degrees opposed away from the starting point, the midline, but in opposing directions, they end up effectively being 180 degrees angular shift apart from each other. But taken together as a pair, they're at right angles to the original orientation of time, which means they are 90 degrees shifted from time, each in their opposite way. So in a sense, the prior half cycle becomes a quarter cycle. The quarter cycle becomes the next half cycle. So it's the half cycle that divides itself into what we would call a quarter cycle, but as far as it's concerned, from its point of view, nothing happened. Nothing got subdivided. It simply became half the angular time frame as before. So instead of a half cycle, now it's a quarter cycle is the reference for a half cycle. So it's the half cycle that's changing its reference in time by subdividing itself into the quarter cycle for that reference, which becomes the new half cycle, and it just keeps doing that. And so the frequency keeps doubling, and the amplitude keeps doubling as well, because it keeps making copies of itself and doesn't dissipate. The prior waves see no impedance to dissipate themselves, to dampen themselves, and so they just keep going on oscillating, but oscillating in the reference of half cycles, because there's no full cycles anymore. And so, the adage, anything that goes up must come down, namely, life can't be that good that it keeps getting better and better, doesn't work in this frame of this kind of world, because you never even reach a full cycle to indicate that the cycle has completed itself. It has returned, the second half has returned on itself so that the bad guy gets his comeuppance and you pay the bill, for your wild partying, the electric bill. No, you never get to that point in the second half of every cycle period of time in which you have to pay for everything that you spent in the first half cycle. You never get there. You never pay for anything. You just keep spending wildly. Well, no, you don't spend, actually. You keep accumulating. So you never, if you have to accumulate your wealth before you spend it, you never get a chance to spend it. You just keep accumulating it until you reach a breaking point in which the circuit can't hold all of this reactance anymore, and it breaks down and creates resistance when it breaks down. It creates resistance that wasn't there just by breaking down, physically breaking down, and then that resistance sees the reactance and immediately overheats, blows up, fizzles, pops, explodes in your face, smoke, flames, whatever, at that point. So, the parallelisms is very uncanny because what we want to do is cause either a coil or a capacitor or both to become a perfect reflector. See, normally they absorb energy and then they discharge energy. And the absorption process takes time and involves a time delay, and the discharge also, likewise, involves a time delay. So, if there's no time delay, then we can get a total reflectivity, a total reflection of reactance in which the current becomes totally reversed to voltage. The current, of course, being reactive voltage, but I won't get into that. It becomes reversed. But in order for it to reverse itself, it has to be in phase with the applied voltage. And so there can't be any time delay. And so there are two ways of creating this kind of reflectivity, this heightened sense of reflectivity of either a coil or a capacitor. And we either use, let's say, a capacitor of very low capacitance in which it becomes saturated very early on, maintains its saturation, and so it can't store any more energy, so now it can reflect. The other way to do it is to use a capacitance that's so ridiculously huge, 1e to the 20, and then it cannot store energy. Why is that? It's because of Newton's law of change. An object in motion wants to stay in motion. Well, if you get a large enough object, it'll actually resist change. And it's not like when the object was smaller, it resisted to a certain proportional degree. It simply will resist infinitely. It won't even accept the change at all and bounce it right off. And so when you get a capacitor of 1e to the 20 capacitance, it's not going to take any energy into itself. It'll just bounce it right off in a reflective manner, creating the reversal of current that we want to get without any time delay superimposed over applied voltage. So that's the other way of doing it. And when it's parallel capacitance in a coil, then the coil will not absorb energy. It'll simply bounce it right off, and so you get reversal of current. Likewise, if the core material is magnetically coupled to a larger mass of iron outside the core to make up the difference for, the lack of geometry, will only allow so much ferromagnetic material to be stored or to be placed inside the interior of the hollow of a coil winding. But if you get extra iron, let's say, outside the core, and it's huge, let's say it's infinite in size, just for the point of discussion, once you get it that large or past a certain point, it's not going to accept any energy. So the coil, it wants to put most of its magnetic field inside its center, not out here. It'll put some out here, but most of it wants to put in here. Now it's not going to be allowed to because the iron is connected to other iron, and all of it is working together. Remember, iron, as an example, already has energy, magnetic energy. It's just a question of the dipoles. The magnetic dipoles are all oriented in different directions. And so we have to spend a certain amount of energy to realign them, to get them to all line up, to show a kind of token gesture, a footprint, shall we say, that will linger in the iron indefinitely until a new orientation occurs to reorient those dipoles differently. Now, it did take energy to reorient the dipoles, but we're not putting energy into the iron because the energy is already there. We're just expending a certain amount of energy to line them all up. Well, if the iron gets large enough, coupled to the iron in the center of this coil, the iron is going to resist getting itself reoriented to such a degree that it won't even accept any. It's not a question of fractional allowance of realignment. It won't align itself at all. It won't want to allow itself to become aligned or realigned or aligned differently. And so it's going to offer infinite resistance against any. And so now what you've got is a condition in which, see, prior I thought it was suppression of back EMF, but in this case it's worse. It's suppression of all EMF, both forward and backwards, because the iron will not want to absorb any EMF, or I should say any reorientation of its dipoles. So now the coil has to get its magnetic field reshaped such that none of it gets to go where it wants to put most of it in the center. It's going to be forced to put it exterior to itself, and it's not going to want to do that. That's against its nature. And what does this sound similar to? It sounds similar to the core acting as if it's paramagnetic. And that's what's so interesting about this three-way analogy. If we manage to somehow make the core material paramagnetic, such that the magnetism of the coil is not allowed to go in there, it's the same as if we had a humongous amount of iron magnetically coupled to the core, the ferromagnetic core. So it's both the same material, it's just we make it large enough to prohibit the absorption or the allowance to have its magnetic dipoles realigned. And so it kind of starts to make sense to me that when all these things are equivalent, you can use each one to try to make up for using an infinite amount of either one by itself. So parallel capacitance in the coil? No, you don't have to go to infinite value like 1e to the 20. If you provide these two other factors, namely you put paramagnetism in the core and you have enough iron associated with this device that it competes against getting itself aligned. So you're suppressing all EMF. And that's what I think the Amman brothers managed to pull off. They put, I believe, it is all speculation, but it keeps getting more rationally correct to intuitively feel that this is what they did. I keep finding reasons to substantiate the guesswork that I'm trying to exercise because we don't know how the Amman brothers did what they did. But if they had a copper tubing as their so-called core to wind their iron windings around, whether those iron windings were tightly packed or whether they just simply had a shell, a basket weave shell at a certain radius around the copper tubing with empty space in between, I don't know. But regardless how they did the winding of the iron winding, it was around a copper tubing, and inside the copper tubing was helium, and the helium had interspersed among itself finely divided powdered aluminum, and either it was reduced metallic aluminum or else it was aluminum oxide. I'm not sure which. And then they had hollow spheres at either end of the tubing extended outside, perched outside either side of the iron winding. And there's other stuff going on there I'm not sure about. But because they were hollow spheres and because the tubing was narrow by comparison to the radius, or diameter I should say, of those spheres, you get the Venturi effect because the helium now starts to reciprocate along the length of the interior of that copper tubing, and it starts looking like Tesla's special generator, the reciprocating rod reciprocating in between the two opposing feet of the two horseshoe humongous main M coils. So you get the reciprocation action, the mechanical reciprocation of the atoms of helium, and then you get the helium responding to any electrostatics applied to it, creating their own electromagnetics, and then you get the iron winding specializing in the absorption of the magnetics to the exclusion of the electrostatics. So you're getting one-sided reactance, namely inductive reactance. And then you're getting a mild eddy style of current traveling through the copper tubing, causing it to behave like an inductor, even though it's not a coil of wire. What else? And the aluminum powder on the inside of the tubing is acting paramagnetically, so that the iron winding wants to concentrate its magnetic field in the center, on the interior of the copper tubing, but the aluminum powder wants to export it and bounce it right back out again and make sure it doesn't enter. So we get all those three factors, and then if you get enough iron mass of iron winding around this thing, then that would be equivalent to, the large iron mass prohibiting any EMF from entering into it. And you get the three of those things working together, and just maybe. Oh, and the fact that it's iron winding conjoins each of the windings. That's probably why they did not bother to use, Nathan Stubblefield did not bother to use insulation on his iron wire when he wound it with his insulated copper winding, because the iron wants to make it look like it's all smushed together into one block. So for all intents and purposes, you could, if you could form this thing from scratch and melt the iron as one big case, so be it. But since these guys had to work from scratch using materials that were available, they had to use iron wire. And Tesla did this. He would create the core of his transformer out of iron winding, out of iron wire, because he had nothing else to work with. And so he couldn't just cast iron it to shape, to fit. He had to work with what he had, and so he worked with iron winding, iron wire. But when you're dealing with iron, and you're dealing with the phenomenon of how iron behaves, it's like antithetical to even think, why bother putting insulation on the wire? It makes no sense, because it's literally moving the geometry of the surface of that iron as if it's not there at the iron. It's obliterating. It's kind of like iron behaves in a collective fashion, whereas copper is more like an individualist, and so you have to protect that individuality by insulating it. But iron, it's not. You can't. See, there's this notion that you can create a barrier to electrostatics, but you cannot put a barrier to bound magnetism. All you can do is reshape a magnetic field. You can't bound it. And so it's going to go through everything. And so that's probably why it's no point to putting insulation on an iron wire, because the insulation will serve no useful purpose. You're not sending current of voltage, or you're not sending voltage through iron wire. You're sending strictly magnetism. So you have to think about it differently, because it's a different material, and so it behaves differently. And so you don't put insulation on iron wire. You just don't do it. And you treat it as if it's a block of iron, and you've simply shaped it a certain way. And you have a certain mass of that iron as well, and a certain placement with respect to the other materials of construction, how they are arranged relative to each other, the geometry of their arrangement. So this is the best I can make out of the situation at the moment, but it just keeps making more and more sense, because it always comes back to Mohs law, the derivative of Ohm's law. We want to invert current relative to voltage, because when we can do that, we can mimic superconductance at room temperature. And when we can do that, we've got over unity, we've got free energy. effectively speaking. So we're not manipulating energy. Energy always exists, over time. It's never created or destroyed, but we can do a quarterback end run and convert energy into reactance by use of power factor correction, by inverting current relative to voltage, manipulate that state of being, because it's very easy to expand or contract it, not create or destroy it. We have to start with something, but by expanding or contracting it, and then convert it back through power factor correction back into electrical energy. That's how we can make it look like energy appeared out of nowhere, because we could have so little energy we can't even measure it, and yet turn it into reactance, expand it to an appreciable degree, convert it back into energy, and now we can see it because there's enough of it to see. And so it makes it look like energy can disappear or appear into nowhere or out of nowhere, when in fact we just can't. It's a question of perspective. We just couldn't see the energy that disappeared or where it came out of, because it was too little where it ended up or where it came from in size and magnitude. Anyway, enough said.